Catecholamines are a group of similar substances released into the blood in response to physical or emotional stress. So the most common ones that people know of, I believe, are epinephrine, norepinephrine, dopamine. So we know that release of those chemicals can have an acute increase of the sympathetic nervous system, which will reduce inflammation of the immune response. So what that tells us is that exogenous modulation of the autonomic nervous system, so the sympathetic nervous system is part of the autonomic nervous system, and by having exogenous or out-of-the-body exposure to those catecholamines, such as epinephrine, norepinephrine, can have an effect on the autonomic nervous system. However, they go on to say that endogenous stimulation of the autonomic nervous system activity may also limit inflammatory response. But since the autonomic nervous system is generally regarded as the system that cannot be voluntarily influenced, this seems unlikely, right? However, the authors go on to say, results from a recently performed case study on a Dutch individual who holds several world records, you know who that is, with regard to withstanding extreme cold suggest otherwise. It was shown that this individual was able to voluntarily activate the sympathetic nervous system through a self-developed method involving meditation, exposure to cold, and breathing techniques. This resulted in increased catecholamine and cortisol release and a remarkably mild innate immune response during experimental endotoxemia compared with more than 100 subjects who previously underwent experimental endotoxemia. So there's a lot to unpack there. So the authors established that the sympathetic nervous system, when it is modulated by giving somebody these catecholamines, these epinephrine, norepinephrine, or dopamine, we can have an effect on the immune response. What the authors are claiming is from a case study, they were able to show that Wim Hof is able to voluntarily impact his sympathetic nervous system by endogenously, meaning inside his body, he's able to release these catecholamines, this epinephrine, and that results in reduced inflammatory response. Now, they say that they tested this via experimental endotoxemia. So what is that? So here you can think of this as the cell of a bacteria such as E. coli. And these E. coli have these substances that make up its cell wall, which are called endotoxin. So endotoxins are the lipid portions of lipopolysaccharides that are part of the outer membrane of the cell wall of gram-negative bacteria. E. coli fall into this category. The endotoxins are liberated when the bacteria die and the cell wall breaks apart. So how could endotoxin cause an immune response in a human individual? Here is a proposed mechanism. So here you have a macrophage, which is a white blood cell type that can phagocytose or eat this bacterium, which has endotoxin in its cell wall. And then as the macrophage ingests and starts breaking down the bacterial cell wall, the endotoxin or the lipopolysaccharide will be released and induce this macrophage to release what are called cytokines. And then these cytokines then can be released into the bloodstream and they can travel all the way to the hypothalamus. And the hypothalamus is this temperature control center of the brain. And in there, the cytokines can induce the hypothalamus to produce these things called prostaglandins, which will then reset the body's thermostat to a higher temperature and cause fever. So what they're saying in this introduction is that compared to normal people, when you expose Wim Hof to this endotoxin, he's able to voluntarily increase his catecholamine release in his body to deal with that innate immune response and not have the same fever-like symptoms that people normally get. So in this study, we, the authors, they say, investigated the effects of his training program. So the training program of meditation, exposure to cold, and the breathing techniques on sympathetic nervous system parameters and the innate immune response in healthy male volunteers during experimental endotoxemia in a randomized controlled fashion. So yeah, like I said, if you talk to Wim and ask him whether he's special or whether anyone can do the things he does, he will say that anyone can do them and he's able to train them. And that's exactly what they did. He trained the people who were volunteers of this study to see if they would have the same increase in the sympathetic nervous system activity and a reduction in the innate immune response. Thanks for checking out that video. I hope you liked it. Here are a couple more for you to check out. And if you haven't done so, please subscribe to my channel.